All right, today we are going to do 4.6, and these are the notes specifically for those who I'm not going to be here because I'm going to be cross country. I just want to really focus you in on what your assignment is asking you to do. And so what we're going to do is we're going to start with the first few problems. You're really doing 3 through 19 odd. That's where we're going to start. So let's look at the first part of the assignment is about solving for x. So I'm going to look at question number 3, and then I'm going to look at question number 11. Okay, just kind of give you some ideas. Number 3 says x squared equals negative 28. And the idea here is that we want to get x alone, because it's just x squared. The answer would be to take a square root. And as I introduce a square root, notice that negative is with the number 28. So I'm still going to put a plus or minus in front like we did in the past. The square root cancels the square, and I have x equals plus or minus the square root of negative 28. Now the only difference between this time and last time so far is the fact that that's a negative number inside the square root. And so as I try to simplify and break that down, it's going to become an issue. Because we know that a number times itself, if you take the same number, a negative times a negative, or a positive times a positive, you're going to end up with a positive. So that negative being there is going to be a little bit of an issue. So the way we're going to write our work, okay, is we're going to actually split it into 3 square roots. Okay? Now we know 28, forget the negative for a minute, can be written as 4 times 7, and 4 has a square root. So I'm going to put the 4 up front, because that I do know. I know the 7 will never come out of the square root, so I'm going to put it there at the end. And then somehow I have to make this number negative. I have 4, I have 7, that makes 28, but how do I make it a negative? I'm going to use a negative 1. Okay? We're going to come back to that negative 1 in just a minute. The square root of 4 we know is 2. Of course, we've got our plus or minus. We know there's a root 7, but the question is, what do we do with that thing? Really, by pulling the negative 1 out, I just have so far kind of avoided the problem of the negative. I just ignored it by setting it aside. But really, there has to be something there. Mathematicians a long, long time ago wanted to be able to solve these problems, or at least talk about them in a simple way. And that negative continued to kind of eat away at how do we solve these. And so what mathematicians did a long time ago is they said, that does not fit on the traditional number line, because we can't come up with a number that is the square root of negative 1. So we're going to define it, and mathematicians defined it as the letter I. Now, the reason they're using the letter I is that it's referencing the idea imaginary. So the number is what we call an imaginary number. Now, in fairness, it doesn't mean that the number is fake or pretend or made up. Really, it does have value. It does mean something. And as you get further into mathematics, you learn a little bit more about what it does and what its purpose is. Its application in physics and in other places in the world is extremely fundamental. Even the concepts of electricity in an AC circuit that we're used to using doesn't work if we don't have this idea of this imaginary value. So the very electricity we use is founded, has a piece of its foundation in this concept of imaginary numbers. And so other than the fact that we're sticking an I in our answer, it doesn't look like there's a big distinction. So big payoff thing that we have to recognize is whenever we have the square root of a negative, we're going to make it into an I, an imaginary value. And then the second thing we're going to do is we need to acknowledge that if I is the square root of negative 1, that if we square a square root, the square root goes away. So I squared would equal negative 1. These are the 2 foundational pieces we have to have. Those are going to be things you want on the top of your page to look at the whole time you do the assignment. As far as breaking roots down, it hasn't really changed our approach. We just stick an I in there because we know it's a negative inside the square root. And so you'll see that on question 7. You'll see that on pretty much every answer you work with today. When we go to question number 11, was the other one I said we would look at. We have negative 5 times n minus 3 quantity squared equals 10. Okay, and our job is to solve for n, so we're going to peel layers away. We'll start by doing things like dividing by -5, because that's really simple and easy to evaluate. We get n minus 3 squared equals -2. Next thing, I can't get into the parentheses until I remove the square, so I'm going to square root, and that of course requires me to put a plus or minus. I now have n minus 3 equals plus or minus the square root of -2. Let's just keep working and then we'll come back and clean all this up later. I'm going to add 3. Now that 3 isn't really part of the square root, so it needs to be separated. So when I write my answer here, I'm going to write that n equals 3, and then I have my plus or minus the square root of -2. And this would pretty much be the answer, except that, again, we don't want that negative inside the square root. So the question is, can we write it as the square root of -1 times the square root of 2? Of course, we have our plus or minus and our 3. The answer is yes, because -1 times 2 still gives me the -2. But we know the square root of -1 is I. So our answer should be 3 plus or minus I root 2. Do not put the I after the square root, because then it might slide itself back in. The way we write sometimes gets a little sloppy. So we always put the I and any other numbers that we pull out in front of the square root. So that's how those are going to look. This idea of 3 plus or minus I root 2, I truly want to make sure you understood that if you do add something after you've done the square root, it sits over on the left of the plus or minus sign. Well, the rest of this is going to get a little easier for a minute. If we look at 13 through 19, they're all basically addition and subtraction questions. I'm just going to grab number 17. This is one where we're talking about a complex number. So imaginary numbers are numbers with I in them. A complex number is a number that will have a real number and an imaginary number in conjunction to each other. So for instance, 8 minus 5i. This has a real piece and an imaginary piece, so it's what we would call a complex number, because it's complicated. It's got both kinds of numbers. And then we're subtracting -11 plus 4i. All right, so if we think about this as just like terms, adding real numbers to real numbers and complex, or imaginary to imaginary, we can treat this a lot like a normal algebra problem and distribute our negative. Now if it was plus, we wouldn't distribute anything. 8 minus 5i. Okay, now I have plus 11 minus 4i. And what I want to do is I want to combine my real numbers and my imaginary numbers. 8 plus 11, that's 19. And -5 and -4 is -9i. Now when it comes down to it, we always want to put the real number first and then imaginary numbers, because we understand and have a firmer grasp of what real numbers are than imaginary numbers. And so we always put the things we understand best first. That's how that whole section through 19 is going to go. Just simple addition, subtraction. Then it gets a little bit messier when we hit 22 through 32. I've only assigned the evens here for most students, but I'm going to change your assignment a little bit. You'll notice it on the board. Instead of doing just what was on the green sheet, I tweaked it just a little bit. And I did that because I really want to focus on certain skills. Okay, and so if we look at 22 through 33, there's two types. There's multiplication problems, and then there's division problems. So if we look at a question like 25, okay, it's a FOIL of two complex numbers. They've got real numbers and imaginary numbers mixed together. So -2 plus 5i. And in the second, we have -1 plus 4i. Okay, and the big idea when we start multiplying is that when you get I squared, it's the same as -1. That's sort of the thing that we have to remember to go back to when we do this multiplication. So we're just going to follow through a normal FOIL. -2 times -1 is 2. -2 times 4i would be -8i. Don't complicate the process. This is supposed to be easy. 5i times -1 would be -5i. And 5i times 4i is 20i. I squared. That I squared is really, really important because, like we said up here, I squared is the same as a negative 1. So I'm going to cross this out and put a negative 1 in parentheses. Okay? So if I rewrite this a little bit, I have 2 minus 13i. Now this becomes minus 20. So you can kind of imagine that when you get I squared, all it really does is change the sign of the number. Instead of being plus 20, the I squared made it minus 20. Now I can combine those, so I should, giving me negative 18 minus 13i. Okay? And we're there. Now that is the multiplication process. The issue most people have with the multiplication is remembering the I squared and making sure that it turns into a negative 1. I have a lot of people that will get 20i right there and forget there was an I for both of them and they should square. The rest of the assignment is about division. And no matter what happens, they all come out basically the same. So let's look at 32. It's as bad as it's going to get. Okay? It's not that bad. It's just a matter of being patient and making sure you're making the right decisions early. 7 plus 4i over 2 minus 3i. Okay, if you remember from when we were doing other simplification in this section just prior to this, you'd remember that there's a specific pattern to use to get I out of the denominator. See, the issue with these division problems is it's complicated because it's complex numbers to try and divide. But I could change this into a problem where I is not in the denominator, which technically isn't I the square root of negative 1? And so by nature we would have a square root in the denominator. All things we're not supposed to have. So because I'm not supposed to have that, I need to get it out. So just like last time where we did things like 1 plus root 3 and 1 minus root 3, if we have 2 minus 3i, we're going to do 2 plus 3i. We don't really care what happens on top. We have to be thorough and follow through, but it's really all motivated by how do we get the bottom to not have an imaginary number. Something really cool happens when we go through and do this FOIL. Okay? Let's just walk through. We get 14 plus 21i, let's see, plus 8i, right? And then plus 12i squared. Nothing special's happened yet. Don't worry about that. At the top we really didn't worry too much. Down here something cool is going to happen. 2 times 2 is 4. 2 times 3i is 6i. Negative 3i times 2 is negative 6i. And negative 3i times 3i is negative 9i squared. Now something cool just happened. You may not have noticed it, so we're going to really focus in for a minute and see if we can make sense of this. Okay, on top, let's acknowledge that I squared is really a negative 1, both places. Okay, so on top, this right here is negative 12, and 14, that should come out as 2. And then I have plus 29i all over. Now, this is where cool things happen. You'll notice that 6i and minus 6i cancel. And because the negative 9 over there had an I squared and that became negative 1, there are no i's left in the bottom. I have 4. And this right here is really a plus 9 because a negative 1 times negative 9 is 9. That makes it over 13. Now, this is a pretty good, happy version of the answer. You could also write 2 over 13 plus 29 over 13 with the I sticking out. This is the textbook standard form way to write it. I'm not going to mark this wrong. This is okay. But this is like gold star, best way to write your answer as separate fractions. Because really we want to separate the real piece from the imaginary piece. And that's why we separate it like that. But that's it. I mean, that is as hard as it gets. Now, one of the things that's kind of a weird thing to think about is this multiplication equals 13, which means that all this time you've thought of the number 13 as maybe unlucky or maybe lucky, but it's been a number on the number line. And if you can think about looking at a page, or like looking at the surface of the earth from a big distance, it looks flat and it's just there. But then when you get closer and closer and you zoom in, you start to see that there are mountains and valleys and lakes and rivers. There's so much complexity to it. The number 13 is not just a standard number. It's the combination of complex numbers, which include imaginary numbers. It's all mixed together. There is some great depth in numbers that maybe prior to now you didn't even know existed. Numbers are no longer just things you use to count. They represent a lot more, and we're going to get into some really cool stuff before we're done. Good luck, and hopefully you survive me being gone one more time.